G'day Internet and Kickstarter backers, my name is Andrew Russell and I'm the lead engine developer on River City Ransom Underground. And in this video I'm going to tell you a little bit about myself, how I came to be making the engine for River City Ransom Underground, and what I've been working on so far. So I'm an independent game developer from Australia, and before I was brought on to help with River City, I was working on a game called Stick Ninjas, which I've put on hold while I work on River City. And Stick Ninjas is a multiplayer 2D platformer shooter with a custom engine and custom netcode. So Daniel Krenner, the producer for River City Ransom Underground, saw this as well as a multi-platform port of XNA that I made, and he asked me if I'd come along and help build the netcode for River City Ransom. And obviously I said yes, and so I started out by building a peer-to-peer session manager, which basically keeps track of all the players on the network playing the game. Now, the benefit of using a peer-to-peer architecture like this is that there's no server that you have to go through, so there's reduced latency. On top of that peer-to-peer networking layer, I made something that we've called a rollback driver, which manages the networked state of the game. So the benefit of the rollback system is that the game doesn't actually really need to know that it's running on the network. Most other network architectures require that the game has sort of this understanding that it's running on a network. So during development, this is a game that I was using to test with, and as you can see, it's just a simple little square moving around game. And the idea was that we would take this and replace the square game with River City Ransom once it was ready to use. Now, as you can guess from the name, the rollback driver basically works by allowing you to take the game state and rewind it to a previous point in time and then simulate from there. And in a later video, I'm going to tell you more about how that enables you to synchronize a game on multiple machines on a network. So what the rollback driver needs to operate is snapshots of the game state. And the way we get those snapshots is using a process called serialization, which basically involves taking all of the objects in the game and converting them to a sequence of bytes, just like you might store in a file or send across a network. Now that sequence of bytes can then be used to recreate an identical copy of the game state, either locally to implement the rollback system or on another machine for the networking. Now when we took this process and tried to apply it to the game state that we had at the time, we found that it was just too complex for most existing serializers to be able to cope with. So Daniel asked me back a second time, this time to build a brand new serializer specially suited to serializing the game state. Now, a serializer is probably not the most interesting thing to talk about in a video because, it just converts data, it spits out a stream of bytes, it doesn't produce any pretty pictures. So you'll just have to take my word for it that I made a particularly fancy serializer with, it was very fast, it had very low overhead in terms of space, and it could cope with pretty much any object graph that you could throw at it. But even this really fancy serializer, it wasn't sufficient to serialize the games that we had at the moment. And so what I did is I made it produce pretty pictures, and here's one of them. And so as you can see, this very quickly identified the source of the problem. Basically, the game state that we had in the old engine, even running a very simple level like the one you can see here, there's already 16,000 objects in existence. So how do we have so many objects, you might ask? Well, partly it's down to the physics engine that we were using. It just happened to make a lot of objects. And partly it's down to a sort of object composition system that we'd made early on in the engine's lifetime, where each gameplay object is actually composed of multiple engine objects, and each engine object defines a specific behavior, and so you could create a gameplay object by piecing together multiple different behavior objects. And, this is a good idea in theory, but in practice, first of all, obviously, there's a lot of overhead involved, and it's also very difficult to sort of think about when you're coding because the behavior for any given object is spread across many different files, so it actually gets very complicated to program. So Daniel asked me back one more time, this time as a full-time member of the team, to help work on slimming down the engine and getting ready for it to run on the network. Now, originally the plan was to prototype a new physics system for the game, because the physics system was what was giving us the most grief. And then once that was completed, we'd use it to replace the existing physics system. Here's a quick look at that physics system prototype, which replaces the physics engine that we were using with a pixel-based 3D engine. And as you can see here, the level exists in 3D space, and each object you can add has some 3D volume to it. Now, what actually ended up happening was that once this prototype was done, it was working so well that we decided to use it as the primary base for the game, and then port across features from the old engine as required. Now, there are a few major reasons for doing that. First of all, it gives us a much simpler base to work all of our code from. So we start off with a simple, clean slate. It means that the code we write from now on is guaranteed to work with this new physics system. So we're not writing code against the old physics system that we then have to convert to use the new physics system. And finally, it means we can turn on the network right away. So any code that we write from now on, we can test it against the networking, and it's always going to work on the network. So I'll leave you today with a look at the game running over the network. So you'll remember that we started developing the network system using this little square game, and now here it is running in the new engine. So this has been the first in a series of technical devlogs for River City Ransom Underground. I've given you a high-level overview of what I've been working on so far, and in the future I'm going to talk a bit more about these topics in some more depth, as well as some other engine features that I'm working on right now. So stay tuned for those. If you have any feedback, please leave a comment. Thank you again to all of our backers on Kickstarter, and thank you very much for watching.